Okay, so we're going to start with number. Our lesson today is 1123. So you can write that at the top of your paper, 1123. Okay, let me get my, should have my things together here. All right, what is a solution in 3 dimensions? Okay, so we're adding a dimension today. Usually we do 2 dimensions, right? And we're going to learn how to solve a system of 3 equations with 3 variables, which you have not done before, okay? What does a system of 3 variables look like, and what strategies can we use, yada, yada, yada. Okay, so before I go to this, I'm going to go ahead to this problem here. And okay, usually we have a system of 2 equations. In Algebra 1, we had something like this. So let's go ahead and write down 1175 here. 11, oh my goodness, that is terrible. Let's try that again. And let's change my ink color. I'll just go with black for right now. 11-75. Okay, we're going to write 12x minus 2y equals 16. I think we had these on the standards quizzes at the very beginning of the school year. 3x plus 2y equals 68. Yeah, and a lot of people like to use photo math on this, and I can tell when you use photo math. All right, if I'm using elimination, right, if I add these 2 equations together, what's going to happen to either my x's or my y's? Feel free to unmute yourselves and answer at any point.
The y's are gonna both the y's will disappear because one's positive, one's a negative.
Okay, good. So that y, since this is a negative 2y and that positive 2y, that's going to cancel. And we're going to add the x's together. The x's aren't going to cancel. And you're going to get 42x equals 14, 84. Okay. And then we would divide and we would get a solution for x, right? 42 divided by 42. And that will go in 2 times. So x equals 2, right? And then we found x, and then we would go back and find y, right? And y would be some number. I plug it in and I get some number, right? And when we solve this, like the first equation is some line, and then the second equation is another line on the xy axis, right? Like this is on a, this is the, let's say this is the x axis, and this is the y axis, okay? And I did probably do it correctly. It should be over here, because it's 2 something. And then the solution where they cross is 2 whatever the solution is. And I could go back and find it, right? So we're looking for a point where they intersect. Okay, we know how to do that. We did that a lot in Algebra 1. That was an important skill. What if we add a variable, a z? Okay, so now I have x, y, and z. And if I add a variable, I need to add an equation because I have 3 equations for 3 unknowns. 3 equations for 3 unknowns. If you wanted to search, do a YouTube search on how to solve these, you could, this is what I would type in my YouTube search bar, 3 equations and 3 unknowns. And a bunch of videos will pop up because I know, because I checked them, because I wanted to try a good video, to try to find a good video to link for you guys, because I know this is a harder lesson. And if you still don't understand after my lesson, although I'm going to do a great job, I'm going to work really hard here to help you understand this. You can also search on YouTube and watch some more. Okay, so if we add a z, we need to add an equation because we have 1, 2, 3 variables. So we need 1, 2, 3 equations to solve this. So we have 3. So we should be able to solve this system the same way that we solve this system, except now we are solving for 3 things. And usually when we do this, right, our solution is an xy. But now our solution is going to be an x, y, and a z. It's going to be a coordinate. And now we have 3 dimensions instead of 2. So this coordinate xy is on a 2-dimensional plane. Z is the 3rd dimension. Okay, so now we're going to have 3 dimensions. So it's going to look like this. Like this is going to be the x-axis. This is going to be the y-axis. And that's one plane. Okay, that's in a flat plane. And then the z-axis is going to go straight up and down. And sorry, I didn't make that. So that's the z-axis, straight up and down. And it's 3-dimensional. Okay, so I'm going to show you this in another slide. Your book has this three-dimensional graphic e-tool. Click on it, use it, play with it. It's pretty cool. Okay, what I did is I put these in here. I put these three equations into the three-dimensional graphing tool. I'll show you what it looks like. I have to clear the screen, so they're going away, and don't worry, you don't have to have that all written down. Let me find the e-tool. Okay, the e-tool. So look, oh my goodness. First, let me back up a little bit. How do you graph? So this is what it looks like, okay? How do you graph on a three-dimensional plane? So here's the x-axis. Instead of going sideways, it is now front to back. Like the x-axis is coming towards you. If you're like right here, right? The x-axis is coming towards you, and away from you is the negative x's. So positive x's go this way, negative x's go that way. And then here's the y-axis going from left to right. Okay, and negative y goes this way, positive y goes this way. And then the z-axis goes up, positive z, and then down underneath this plane, if you go, would be down z. So if I wanted to graph the point 2, negative 4, 4, this is the graph of 2, negative 4, 4. I would go forward 2, I would go to the left 4, and up 4. So it's in space, it's above this plane. See, this is the XY plane here. So this point 2, negative 4, 4, I'm coming forward 2, going left 4, and up 4. So that is the coordinate negative 2, 4, 4. Okay, so that's what you're finding, a point in space. Okay, if I wanted to do this one, I'm going to enlarge this one so you can see it. If I wanted to do a negative z value, I just wanted to do one that has a negative z value, make it bigger. Okay, make it bigger still. If I wanted to graph negative 3, 3, negative 5, sorry, somebody's, negative 3, 3, 5, negative 3 goes back 3, positive 3 goes to the right 3, and the negative 5 goes underneath this plane. So this point is sitting underneath this XY plane. Okay, so that's a three-dimensional. Okay, and so that is a brief like, oh, that's what these coordinates mean, because we're actually skipping the section. Honors does the section right before this 11.2.2, and it explains this stuff. But I like for you to understand what you're doing and not just tell you, okay, solve the system of three equations. So this is just an overview of what we're skipping for 11.2.2 that the honors does, but the academic class doesn't have to do. Okay.
Mrs. Wakefield,
Yes. Hold on one
for when
second.
we solve these on the worksheet, are we gonna have to graph these as well?
No, you don't have to graph these. I'm just showing you because, you know, it's better to understand what you're doing. You do not have to graph them. If you were in the honors class, then yeah, you would have to graph them. Okay. All right. So what does an intersection of three planes look like? Okay. So it could look like this. There could be no intersection. I borrowed this from the internet. Oops, the words don't move. Three planes. So every equation, the three equations that we have is a plane, right? Is a flat surface. So this is the first equation. This is the second equation. This is the third equation. They could not intersect, and then you would have no intersection, and your answer would be, oh, there's no solution, right? If they're like this. But most planes are not going to be parallel planes like this. If I tweak the planes a little bit, let's say I move them like this, they're going to intersect, right? Do you see where these intersect? They intersect right at this line right here, that line. And so that line has an equation. It's like 3x plus 4y equals 10 or something like that, right? And we could find that equation to that line. But what we're looking for is this situation right here, where the three planes intersect at a point, and the point would be right here. So let me put my pen up. Let me get my pen. Okay, so the point of intersection would be right here. I put it in blue. I should change the color because it blended into the thing. So that is the point of intersection of all three, of the green plane, the red plane, and the blue plane. And that's the point that we're looking for. Okay, that's the situation we're looking for. But once in a while, you're going to have systems that don't have answers, because this pink one and this blue one and this green one, they intersect, but the pink and the green only intersect at this line right here. And then the blue and the green intersect here. So there's no intersection of all three. Same thing with this. The green and the red intersect here. The blue and the green intersect here. And then the blue and the red intersect here, but there's no one intersection for all three. So we say this has no intersection. This has no intersection. These have no intersection, but these two have an intersection. And all your homework problems have an intersection point. They have an answer. The worksheet for the worksheet. In our classwork today, we'll investigate a couple problems that don't intersect. But we're going to give you problems that have an intersection point on a test or something like that. All right. And yeah, this should be on your final, definitely. All right. Not a lot, maybe 1 or 2 problems on the final, not a ton. But like I said, you're going to need to do this on your project. Okay, I need to clear the screen. I need to go. So let's do our first example. Okay, now that you kind of understand what a 3-dimensional point looks like. So when I put those 3, your book tells you to put the 3 equations in the grapher, and this is what's going to happen. Look, you see 3 different planes, right? So this first one is the red plane. The second one is the orange plane. And then this last one is the yellow plane. And they all intersect somewhere. But can you see where they intersect? No, it's kind of hard. It's like they intersect somewhere around here, but I can't see the coordinate, right? So let's use algebra to solve this, to find exactly where is their intersection point. So I'm going to show you how to solve this system using algebra. Okay, and that's our first example, what we're going to do. So we're going to do 76 here, which is solve it. Well, 76 is use the graphing tool. You guys can do that. You can't write it on your paper, right? Just write like we use the graphing tool to solve it in class. You can write that for 76. And 77 and 78 tell us, okay, let's use algebra to solve it. So you can mark this as 77 and 78. Okay, I'm going to move this out of the way because it's just a lot of words and I'm going to delete that actually. So 76, let me write 77 and 76 or 11 dash, I'm just going to write 77. 76 goes together. So these are our 3 equations. Let's write them down. Okay, negative 2x plus 3y plus 4z. You're going to need to write this down. Equals 1. And make sure you don't make any mistakes. You make one little mistake and your whole problem is going to be wrong. 6. So that's the first step, is make sure you copy down the equations correctly. Plus 4z equals 11. Last equation, 3x plus, minus 3y plus 2z equals 10. Okay, let's take a look at these 3 equations. Okay. Let me move this out of the way. So much. And let's see which variable we want to eliminate first. Okay, so let's look at the x's. You see, look at the coefficients, -2, 6, 3. Okay, we would have to change all of them to 6x's and make one of them a -6x to cancel these out, which, okay, that is doable, but let's go on to the y's. Let's look at the y's, okay? So here's my y's. I have a positive 3y, a negative 3y, and a negative 3y. Would it be easy to cancel these out if I like added the first 2 equations together? Yeah, those would cancel, right? And then if I added like the first and the third equation together, those would cancel. If I added these 2 equations together, that 3y and this negative 3y would cancel. So that would be a good variable to eliminate. Okay, I wouldn't pick the x's because I'm going to have to multiply this by 3 to get it to be 6. I'd have to multiply this by 2, and that's just too much work. Why do that when these will cancel when I add them together? So I'm going to pick to eliminate the y's. I could pick the z's too, but then I would have to multiply this one by like -2 to get a -4z, and that's too much work. I mean, it's not too much work, but this, I don't have to multiply anything. So I'm going to pick to eliminate the y's. You don't always eliminate the y's, but this one just happens that the y's are all the same variable. Okay, so I'm going to eliminate this one. So I'm going to erase this stuff that I circled, that I wrote. Let's use the eraser instead. Okay, so I want to eliminate the y's, okay? And you can't do this all at once. You can't add all 3 together. You can only add 2 equations at a time. So I'm going to pick the first 2 to add together, right? I'm going to pick 1 and 2, and I'm going to label this. So this is equation 1, this is equation 2, this is equation 3, right? So I'm going to add 1 and 2 together. So I'm going to rewrite them. Negative 2x plus 3y plus 4z equals 1. The second equation was 6x minus 3y plus 4z equals 11. Okay, when I add these together, right, one of the variables is going to cancel. The y variable is going to cancel, which is going to leave me with an xz equation, an x and a z. Okay, so let me change colors here. When I add negative 2 plus 6x, that gives me 4x. When I add 4z plus 4z, that gives me 8z equals, and then when I add 1 and 11, I get 12. Okay, so this is my new equation. So I'm going to call this like equation 4. Okay, I have equation 1, 2, 3. Now I have an equation 4. Okay, well, I need to create another equation with just an x and a z, and I have to use 2 other equations. I already used 1 and 2, so I can't use those 2 together. Well, why don't I use 1 and 3, right? Because this is a positive 3y, and this has a negative 3y. If I add them together, it'll go away. So next I want to use 1 and 3. So let me undo that. Okay, so I'm going to do 1 and 3 right here. 1 and 3. 1 is negative 2x plus 3y plus 4z equals 1. That's equation 1. I'm going to add it to equation 3 here. 3x minus 3y plus 2z equals 10. Okay, I picked 1 and 3 because what's going to happen with the y's right here? They're going to cancel, right? And you have to cancel the same variable that you canceled last time. I canceled the y last time. I have to cancel. If you cancel the x's instead, then you'll get a yz equation, and that will be no good because you'll have an equation with a y and a z, and it won't cancel with this one. Okay, so when I add,
how come you can use the first equation if you already used it with the second equation?
because I'm using it with a different equation, right? Like the first time I used 1 and 2, now I'm using 1 and 3. So it's going to create a different equation. Okay, so this is going to be equation number 5, right? So when I add 3x minus 2x, that's going to give me x. When I add 4z plus 2z, that gives me 6z. Then when I add 1 and 10, that gives me 11. So, and I have this new 5th equation, right? Because I added equations 1 and 3. Now I have a new equation. It has an x and a z, just like this one has an x and a z, right? So I'm going to put this equation right underneath equation 4. It's going to say x plus 6z equals 11. Okay. Okay. Now, this is just like what we did in Algebra 1. We have 2 equations and 2 unknowns. So we need to either get rid of the x or the z. Which one's easier to get rid of, guys? The x or the z?
X?
Definitely the x, right? Yes, that's correct. So what I want to do is I need to multiply this by -4, right? To make this cancel with the +4. So I have to multiply this whole equation by -4, right? To create 2 new equations so I can add them together and eliminate the x. So the first equation, number 4, I'm not going to change anything. Number 4 is 4x plus 8z equals 12. Now I'm going to multiply the bottom equation by -5, and that will still be equation 5, but it'll just be multiplied by -4. -4 times x is -4x. -4 times 6z is -24z. And then -4 times 11 is -44. Okay. When we add these 2 together, voila, the x's are going to cancel, and we're just going to have z's. So -24 plus 8, what does that give us? Is that 16? -16z equals, and what is 44 minus 12? 32. So -32. Okay, when I add these 2 together, I get -32. Then I divide by -16, divided by -16. Well, 16 goes into 32 2 times. So z equals 2. Okay, so what we have found is we have an x, we have a y, and a z that we're looking for, right? We found this variable is 2. Okay, we found this is 2. Now we need to find x and y. Okay, so let me go back and erase this part right here. Okay, so how do we find x and y? Well, we need to use one of the equations that has an x and a y in it. It's better to use an equation that only has 2 variables. So number 4 and 5 only have 2 variables, right? And which one's easier? Guys, look at number 4 and look at number 5. Which one's easier to use, 4 or 5?
5.
5. You're correct, because the coefficient is 1. Anytime you have a coefficient of 1, that's the easier one to use. We can solve for x right here, right? By plugging in our z value. We're going to plug in this z value of 2 into here. So x plus 6 times 2, because we've solved z to be 2, equals 11. Okay. And this is 12, right? So this is positive 12. So I'm just going to go ahead and minus 12 from both sides like that. Just to save some steps here. So x is going to equal 11 minus 12 is negative 1. So we solved for x now. We've got this guy is negative 1. This guy is 2. What's the last variable we need to solve for?
Y.
Well, y, good. And we can't use our short equations to solve for y because there are no y's in the short equations. There's only an x and a z and an x and z. So we have to go back to one of the original equations to solve for y. Does it matter which one I pick? No. Just pick the easiest one though. I don't know which one looks easier, 1, 2, or 3.
2.
2? Okay, I think 1's a little easier, but you can pick 2. You're going to get the exact same answer. I'm going to use 1 just because, I don't know, it's equal to 1. But we can use 2. I'll use 2 just because you picked 2. 2. Okay, you can use 1, 2, or 3. You're going to get the same answer because this point goes through all 3 of the problems. So if I use 2, 6 times 6x minus 3y plus 4z equals 11. So we're going to plug in our negative 1 for x right here. 6 times negative 1 minus 3y, we don't know what y is, plus 4z is 2. So I'm going to do times 2 equals 11. Okay. So 6 times negative 1 is negative 6 minus 3y plus 8. 4 times 2 is 8 equals 11. I'm going to go ahead and add these together. 8 minus 6. 8 minus 6 is 2. So I'm going to put negative 3y plus 2 equals 11. And then I'm going to bring the 2 over. Minus 2 minus 2. There are other ways you could have done that. As long as you end up with the same answer, that's fine. Negative 3y equals 9. Hey, 3 goes into 9. Yay. I need to move my bar out of the way. Okay, so divide by negative 3, divide by negative 3, y equals negative 3. Okay, so we found x, y, and z. Okay, you can't just leave your answers like this and say, oh, x is this, y is this, z is. We want you to write it as a coordinate. Okay, so your answer needs to be written like this. So it goes x, y, z, alphabetical order always, right? So x, we start with x. X is negative 1. So our solution is negative 1. Y was negative 3. Negative 3, comma, and then z, 2. So this is the point in the three-dimensional plane where the 3 planes intersect. These 3 planes intersect at negative 1, negative 3, 2. That was really hard to see in the picture that we did, but now we know exactly, hey, we know exactly where, I was going to go back to my other screen. Let's see. We know exactly where these 3 planes, sorry, I had to leave there. I don't want to erase the writing yet. So where these 3 planes intersect at negative 1, negative 3, negative 1, negative 1, negative 3, 2. So right there. Okay. So sorry, I'll put that back so it's not confusing. So that's the work. And you see this takes time, right, guys? And if you make one little mistake, like the whole thing is gone. And my advice to you, if you get stuck, start all over. Okay, don't try and, you can try and find your mistake, but don't ask me to find your mistake, because when there's all these steps, it takes a while to find the mistake. Just start all over. Like, okay, say new piece of paper, start all over. Okay, so if you can't find your mistake, because it's really hard to go back and find a mistake if you made a mistake. And I'm so glad I didn't make a mistake on this one, because I'd be like, where is it in all this work? Okay, so that is how you do 76. Okay, and that was 77 also. So I need to erase this and go on to the next one. So I'm going to erase it. Okay. And next problem, move this over. Okay, 79 is the next one. Practice using your algebraic strategy.
What about 78? Was that part of the last one?
Let me see, what did 78 say? Yeah, it was part of the last one. It was just like solve it algebraically. So don't worry about it. You could just write, you know, that last one was 77 and 78. Okay, so 79 has 4 problems and they want us to solve them. Okay. We don't necessarily need to solve all of them, but yeah, but we can. Okay, so I'm going to start with A here. Okay, look at the X's, look at the Y's, look at the Z's. You guys tell me which variable is easier to get rid of, to eliminate if I add these equations together. Will the X's go away? Will the Y's go away? Or the Z's go away if I add them together?
The Y.
Again, this one is a Y, right? You could get the X's to go away if you multiplied the top by -2, then it will, and then you can add it to the second equation and the third equation and it will go away. But here, these are all positive and this is negative. So I can use these two and these two to add them together to get them to go away. Okay. Do we actually want to do all that? I think I do. I want to do at least one more example with you guys. Well, but I want to look at B here. Let's look at B. Maybe we'll do one of these ones instead. Okay, look at your X's, look at your Y's. Ooh, this one doesn't have a Y. And then look at your Z's. There's 3 Z's. Which one will be easier to go away? But what's going to happen when we add the first 2 equations together, guys? Look at the first 2 equations. Let's write B down. We'll come back to A. So leave some space for A. Okay, leave like a big chunk of space over here. Let's go ahead and write B.
Wait, isn't there no solution because the first 2 equations are the exact same, but the answer is different?
Exactly.
Yeah.
Exactly.
I just noticed that because one equals 60, the other equals 120.
Right. So these 2 equations are exactly the same except for the right side. So if I multiply the second one by -1, right? Then won't all these become negative and cancel with all those? So let's write this down. 20x plus 12y plus 15z equals 60. I'm going to multiply the second equation by -1 to get the 20 to cancel with the -20. So -20x minus 12y minus 15z equals -120. Okay. And then what those 2 gentlemen just said right now, what Ethan and Kyle just said is, hey, this is going to cancel, that's going to cancel, and that's going to cancel, leaving you with no variables, which is 0 equals -60. And 0 does not equal -60, right? So when we did this in math 1 and math 2, when you get a solution with this, like this, it means no solution, right? Because usually it means, hey, the lines are parallel, so they don't intersect. Well, it means these are 2 parallel planes. So I have a plane, which you just draw like a rectangle, and another rectangle like below it. So these 2 planes are parallel, so they're not going to intersect. This third one probably isn't parallel, so it's going to go through like this. It's going to go through both of the planes. If you can draw that, awesome. If not, you know, just take your best shot. So yeah, we have 2 parallel planes. So this is going to be no solution. Did I just write no solution or did I show some work? I definitely, yeah, there's definitely like a step to show, right? don't just write no solution, put y there. Show that, oh, we got 0 equals negative 60. So that's the work you need to show. Okay, so there's an example of no solution and what it looks like. All right, let's look at C here. So I'm going to bring C up to the top here. Let's look at C. Let's look at the X variables. 5, negative 2, 3. Can we easily cancel those? Not really. 4, 2, negative 6. Can we easily cancel those? We'd have to make a lowest common multiple. We could do it, right? What is like the lowest common multiple of 4, 2, and 6?
2.
That's lowest common factor. But lowest common multiple, so a number that's bigger than 4, 2, and 6, that all are multiples of 4 and 2, 6. What's a number bigger than 4, 2, and 6? They're all multiples of
12.
12, right? Good. So I would need to change all these to 12. So I'd have to multiply this by like 3, right? To get that to be 12. I'd have to multiply this by 6 to get that to be 12. And I'd have to multiply this by 2 to get that to be a negative 12. And you want some of them to be negative and some of them to be positive. And that's okay because we want them to cancel. So we could do it that way. And actually, we probably are going to do it that way because look at the Z's. We're going to have to find the lowest common multiple of 5, 6, and 1. What's the lowest? So a number bigger than 5 and 6 that multiplies. That's a multiple of 5 and 6. What would that be?
1.
What's 5 times 6?
30.
30. So the lowest common multiple. So I'd have to multiply this one by 5, this one by 30, and this one by 6. We could do that, but you could do that. And I do want to do an example where we eliminate another variable besides y. I don't like that your book set it up that we're always eliminating y. You don't always eliminate y. We can eliminate the z's. I could make that 30. Okay, but I'd like this to be smaller. 12 is smaller than 30. So I would pick to eliminate the y's. I wish we could do like a x. It's bad that they set it up like that, but we can do that if you want to. So this one is probably going to have some solution, right? There's going to be like a number. There's going to be some number x, some number y. This one probably is going to have a solution. Okay. And then D, the last one over here. Let me move this one up here, make it a little bigger. Okay. What do you notice about the x's, the y's, and the z's for this problem? Are they all going to eliminate? Let's copy this one down because it's interesting. So let's copy it down. D. Get my pen here. Let's write in blue. D. Okay. So 6x plus 4y plus z equals 12. I'm going to go ahead and multiply the second one by -1. Why am I doing that, guys? Why am I multiplying the second equation by -1?
Because you have all 4s in the y slot.
Okay, because I want these to eliminate when I add them together, right? Minus 2z equals -12. Okay, so when I add these two together, right, the x's are going to go away, the y's are going to go away, but the z's are not going to go away, right? That's not going to cancel. -2z plus z is -z equals -12 plus 12 is 0. If I divide by -1, I'm going to get z equals 0. So, oh, we got a solution for z. Okay, so this, they don't all eliminate. So this has a solution kind of. Okay, so that's for if I use 1 and 2. Let me add 2 and 3 together and see what happens to that. Okay, so I'm going to add 2 and 3 together. So I'm going to pick equation 2, equation 3. But I'm going to multiply equation 2 by -1 again. So I'm going to use this part that I multiply by -1. -6x minus 4y minus 2z equals -12. That is equation 2 multiplied by -1. Equation 3 is 6x plus 4y plus 3z equals 12. What's going to happen to the x's here? cancel?
They'll be canceled out.
Good. And the y's are canceling out, but the z's don't cancel again, right? So 3z minus 2z is z equals, and then again, negative 12 plus 12 is 0. So again, I got z equals 0. Okay. Now, if I plug in 0, but can I solve for x and y? Can I ever solve for x and y, or are they always going to cancel out?
They're always going to cancel out.
They're always going to cancel out because they have the same variable. So, but there is a solution for z. So if I make all these equal to 0, this is 0, this is 0, this is 0, then they all become the same equation, 6x plus 4y equals 12. So the solution is this line. The solution is 6x plus 4y equals 12 when z equals 0. That's your solution. Okay, we don't get a point, right? We're not getting a point. It's a line because it's 3 planes intersecting. So these planes are intersecting in a line. Okay, so go ahead and write this down. And I'll show you the picture of what that looks like before, because I have to erase this.
I have a quick question.
Yeah.
So when you only get one value for x, y, or z, it will always be a line like this? Will we always have to write it as that solution?
No, we only got one value, but it's because these other values were all the same. Okay, because like if I do this, I'm going to get one value. Let's say I get y. Let's say I get y equals 2 for this one, right? I don't know what the answer is, but if I get y equals 2, well, I can plug in y into the equation and then I'll get an x and a z. But see how these are different and these are different? So I will get x value and I will get a z value. It's just,
Yeah, I knew that part. I was just wondering, like, if it is always like this, where you only can find a single value for x, y, or z,
yes.
and they don't work for the other ones, will they always come out as a line
Right.
solution?
Yes, it means that, and it's not no solution. There is a solution. The solution is this line right here when z equals 0. This is the solution. This is not a no solution like this problem over here, because here they all went away. But here, if 2 of them go away, but 1 stays, then you're going to have a solution. You're going to have a line for a solution instead of a point, instead of x, y, z. Okay. Okay, so I'm going to erase this and show you what solution that was. That is basically like this solution right here, where our solution is this line right here. Okay, so the planes, they're not parallel, but they're all going in the same direction. So their solution is a line. That's why we get that, okay? And okay, I could do A or C or one of the other ones we didn't do. I erased all the writing. I forget A or C. Do you guys want me to do A or C, or do you get the idea of this?
I think I understand it pretty well for now.
Pretty well. You guys, that's one vote.
Yeah, I understand it too.
You're good? Okay. So if I were to do A, I would like multiply the second equation just to head you off in the right direction. Oh, sorry, my pen is not showing up. Okay, so I would multiply like the second one by -1, right? To get this to be a -y. And then I would add these two together. And then that would eliminate the y. And then I would add these two together. Oh, sorry, I didn't see. I didn't see. If I multiply this by negative, that's going to be negative. So I could multiply this one by -1 and add these two together, and then not multiply this by -1 and go ahead and add these together. There's lots of different ways to do this, as long as, or I could add like this one plus this one, the first one and the third one, to get those to go away. And then I could add the second and third one. I would probably do it that way better. Then I don't have to multiply by anything. And then I'll get an equation with an x and a z in it, and then a number, and I'll get another equation with an x and a z in it, and a number, and then I can solve for x and z. Okay, just like I did the first one. So I will upload that example that I did to I will upload this video. So if you do get stuck, you can go back and look at the equation. I'll also upload a YouTube video as well for those other ones. I wanted to take a look at your homework really quickly, just to mention a couple things from your homework.
Miss Wakefield, I had a question about the about A.
Yeah.
So I was wondering if so you were talking about like adding the equations 1 and 3 together. After you add those together, like what that creates, could you add that to 2, or would you have to add 2 and 3 separately and then add them together?
You'd have to add 2 and 3 separately, because if you add that new one, it's going to have an X and a Z, but it's not going to have a Y, so your Y won't cancel.
Thank you.
Okay, you're welcome.
Can I also ask a question?
Yeah, sure.
Do you know what real world application these equations have? Like what they're used for?
Well, you would, if you needed to find where 3 planes intersected for some reason, I'm not sure. Maybe you're looking for something in space and you want to see where, 3 satellites are orbiting, and you want to see, are they going to collide somewhere? Where are they going to collide? Anything in space where you have 3-dimensional space, you could use this for. So it doesn't have to be satellites. It could be anything. It could be 2 planes. Where are 2 planes going to collide? If they're flying, you don't want 2 planes to collide. So you want to find at what point are they going to collide. So there could be many applications for this. Anything in 3D space, you could use this for. So, yeah.
Thank you.
You're welcome. So for the homework, the 4 problems that I'm having you do, I wanted you to notice that 2 of the problems I picked, like right here, zoom in here. Number 3, notice number 3, it only has, my pen back, it only has 2 variables here, but then it has R, S, and T, and R, S, and T is just like X, Y, Z. If you want to change them to X, Y, Z, you can, but just leave them R. So this one doesn't have an R, right? Like no R, right? So since this doesn't have an R, what do I have to do? I have to use 2 and 3 to do what?
Remove the R's.
Remove the R's. So I would multiply like the second one by -1 probably, right? To get this to be a -5, and then add them together. Then you'll get an ST equation just like this one. And then you could add this one with your new ST equation once you add 2 and 3 together. Okay, hopefully that makes sense. And then number 12 that I picked is also of that vein. So let me scroll down here. Number 12 is very similar. It only has an X and a Y there, right? The second equation only has an X and Y. So what does that force me to eliminate for these 2 equations right here?
Z.
Z. So I would need to, what would I need to multiply the third equation by to get rid of this?
-2.
I'd have to multiply by -2 to get that to be a +6Z, right? And then once those Z's go away, then I'll have just an XY equation, just like this one. So I definitely want you to try those. So there are 2 examples like that, and all of these have a solution. If you notice down here, right, they all have a solution. None of these are no solution. So the solutions are there so that you can check and see if you're doing, you get one problem and you're like, oh, I got Z equals -4, yay. Oh, I got Y equals 2.5. That's not right. So I did something wrong. So that you definitely want to check your work while you're doing it. And there's a lot of work to show on these. Okay. All right, guys. So you get to go to the 4 problems. Please submit your work. Let me stop this video here.